Okay, our next video is going to be on multiplicity of roots. I know it's kind of 2 video lessons in a row, but the good part about these videos is the homework and the understanding is quite easy. Should be anyways. So, multiplicity of roots or x-intercepts. We're going to take a look at that and look at their behavior and what happens. First thing is factors. So this example right here at the top left is a linear equation, and we're going to look at its factor. Instead of looking at it as y equals mx plus b, we're going to look at it as a factor. And we're going to say, what is its root or x-intercept? And that would be x equals -3, right? We got that by just solving that function for 0, getting the x-intercept at -3. The multiplicity is how many times did that factor or root occur? And we would just say it occurred once. So its multiplicity is once. But what's more important is that 1 is an odd number. Okay? And when you have a x-intercept occur as a factor an odd amount of times, 1, 3, 5, 7, it has a similar behavior as the graph through the at the x-axis. And the behavior for an odd multiplicity is it crosses through the x-axis. Meaning it comes up from one end and through the other. So here's just a little rough sketch. I'm going to go to -3. I know this is linear, and obviously it will go through the y-intercept of 3. But you'll notice that the important part is here at the 0, there it is, the root, the 0, it comes from underneath the x-axis and comes right through out the other side like a needle going through fabric, right? That's how we're used to seeing most of our x-intercepts behave. Okay, our next one is the same factor, but now it's occurring 3 times. So if I solve it for 0, I'm still going to get -3. It'd be a little bit redundant to write it out 3 times and showing you, right, those would get me -3 3 times. And that's what we're talking about. What is its multiplicity? The multiplicity is it occurred 3 separate times, even though the x-intercept is the same. Its 3 is still odd, so we say it has an odd multiplicity, so it's still going to cross through the x-axis. This time it's a cubic, it's not linear. And what happens is, if you know, as a cubic starts off like this, but now it just flattens out before it crosses through. So the higher the degree, if you zoom in right here, the flatter it gets on both sides, the top of the x-axis and below the x-axis. Notice when it only occurs like once, it like goes straight in and straight out. There is no flattening of the curve around the x-axis, just in and out. Here, notice that the higher the degree, the more curvature, or the closer, it's almost like on the upper end, it's like an asymptote, but then it finally comes out through the x-intercept and then kind of comes out this way and up. So for an example, like if we had one that was like, maybe we had f of x is equal to, let's do x minus 3 the other side, and it was like to the 7th. And okay, here, we'll just do it on the same graph. Here's +3 for this second example. Then what happens is it's even going to flatten out more, almost looking like a constant function. So that's what happens the larger that odd power. It's still going to cross through. it just flattens out around that x-axis. Okay, so next one is what happens when we have a x-intercept happen an even amount of times. So here is my next root, and it's going to be x equals -2, and that occurs twice. And that's an even amount of times because 2 is an even number. So my factor occurred twice. Therefore, my x-intercept occurred twice, which is an even amount of time. And this one, we call it touches or bounces, however you want to talk about it, at the x-axis. So you'll know this one pretty well because it is a quadratic and it's shifted left too, right? Talking about our shifting. And notice my vertex is the x-intercept. So it bounces. It never actually goes through. It's kind of like a ball. Comes, hits that floor and bounces back off, or it touches and comes back. But it does not break through to the below the x-axis, so I have negative y outputs. So it just is at 0 is the range from 0 to infinity. Okay, so what happens when I have these larger? I still have x equals -2 as my x-intercept or my root. Now it occurs 4 times, which is still an even amount of times. It's still going to touch or bounce, whatever you want to say, I don't care. And I'm still going to go to -2. But again, instead of it being U-shaped, it almost looks like a football goal. And it just U's out more. Whereas this one, right, it looks kind of bounces, comes off quickly. This one almost looks like it scrapes the whole floor, but it doesn't. It just approaches the x-intercept at a kind of a slower pace getting there. Okay, so our next section is just describing if we have a bunch of a polynomial is going to have lots of different x-intercepts. And so what we want to do is talk about the zeros and how many times they occur. So the first thing is the degree of this thing. It's pretty easy to find out. We'll throw that in there. This is a quadratic times a linear times a linear. So a squared times a first is a third times another first degree polynomial is a fourth. This is a fourth degree polynomial, right? A quadratic times a linear is a cubic times another linear is a quartic or a fourth degree. Okay. Now, I only have 3 unique factors though. So let's start by this one. This x-intercept, right? I'd set it equal to 0 and I get x is equal to a half. That only occurs once, and that is odd, and it crosses. Okay, my next one is x equals -2. That occurred once, which is an odd amount of times. It also is going to cross through the x-axis. Remember, crossing through the x-axis is more frequent than the bounce or happening more than happening an even amount of time. Now, remember, whatever my degree is how many zeros or solutions or x-intercepts I have. So right now I have 2 x-intercepts. I need 2 more. Notice my x is squared. So I'm going to get 2 at 0, which is an even amount of time. So this one is where it bounces. Okay. Now, if we want to find the leading term or the y-intercept, this is not a difficult process. what you're going to do is any polynomial, when you multiply them together, if you multiply all of your firsts together, you will get your leading term. So here's my first, x, 2x, an x, and a negative x squared. And I'm going to multiply those together. So I get 2x times x, which is 2x squared, times a negative x squared, which is a negative 2x to the fourth. Okay, and I could easily get my end behavior with that. That would be an even negative, so my graph would be going down and down from left and right. And now if I wanted to get my y-intercept, I'm going to multiply all my lasts. And this one's a little bit tricky because -1 times 2 is -2. This one doesn't have a last, so you can either think about it as being 0 or however you want to think about it. But because that's just a regular old x squared, it doesn't have a constant term, my y-intercept is going to be at 0, 0. Okay, so next one. I'm going to, let's look at these. I'm going to work backwards again. This is x-intercept at 4, doesn't matter the order. This one's at 2. And this one, well, it's a two-step, right? I'm going to have to add that 1 over to the other side and then divide by 3. So I get a third. Okay. So if you look at the power, sometimes these are written in exponential form. So we can tell that this one occurs 3 times, the next one occurs 2 times, and the last one occurs once. We just don't have the 1 there. Okay, so I know my 4 occurs once, my -2 twice, and my 1/3 3 times. Odd, even, odd, odd multiplicity crosses, even touches, odd crosses. Those are your two options. Okay, so my leading term this time is tricky. Okay, here's why. This first factor that I have written in green doesn't just occur once, it's occurring 3 times. So this one is going to be 3x times 3x times 3x, which this one is going to give me a leading term, or just a term of 27x cubed. That's its first. This one in yellow occurs twice. So if I multiply that factor twice, its first, it'll get me x squared. Sometimes it's easier to write these out all the way in factored form, repeating it 3 times, 2 times, and this one's just 1. This orange one, right? My x just happens once. And so now this would be 27, and then 3, 4, 5, 6. So x to the 6th power. Okay. Then my y-intercept would be multiplying all of my constants together. Okay, well, this -1 is going to be multiplied by itself 3 times. If you would rather look at this written out in factored form, what I'm talking about is this is x 3x minus 1 3 times x plus 2 twice and x minus 4 once. Instead of writing it out like that, that's how I got 27 last time I multiplied all my firsts together, right? And now I'm going to multiply all my lasts together to get my constant term. So I get -1 times -1 times -1, which is -1, times 2, which is -2, times 2, which is -4, times a -4, which is a positive 16. So the ends of your graph are really easy to find. By multiplying all your firsts together, you get your leading term. Multiplying all your lasts together, you get your y-intercept or your constant term. Okay, and We'll pick up on this on Monday.